Hello folks, welcome to today's video. In the last video we defined what a perfect square and a square root is and how we can use our area model to explain perfect squares and square roots for rational numbers. So what we're going to do is take a look at a couple of example problems today. So here's our first example. Given the following square roots, find the perfect square. So again, if I have the square root and I want to find the perfect square, what I need to do is take that number, so 9, and I need to multiply it by itself. So 9 times 9 would be 81. 2 over 5, again, same thing. 2 over 5 times 2 over 5. And if you haven't seen my videos on rational numbers yet, the way that we do this multiplication is we multiply across the top and we multiply across the bottom. So 2 times 2 is 4, and 5 times 5 is 25. So 2 over 5 would be the square root, and 4 over 25 would be the perfect square. And 1.5, we can do that multiplication. Again, if you haven't watched my rational numbers video, we can multiply 1 by 1.5 times 1.5 by thinking about it like 15. So 15 times 15 is 225. And then we just have to kind of think about where the decimal is going to be, right? So 1.5 times 1.5 is actually 2.25. Okay? So we can also work our way backwards, or we can decide if things will be perfect squares, right? So yes, here's my square root, and I can multiply it to get by itself to get the perfect square. But then if we have a perfect square, we can work our way backwards to see, okay, well, is this rational number going to be a perfect square? So in order to determine whether a fraction is a perfect square, you must reduce. So how do we reduce a fraction? Well, when the numerator and the denominator have a common factor, meaning they can both be divided by the same number, then we do that division. So if I wanted to determine if each of the following fractions is a perfect square, well, what we need to do is we need to look at our fraction, 12 over 27, and we need to ask ourselves, can 12 and 27 be divided by something? And the answer is yes, they can both be divided by 3. 12 divided by 3 and 27 divided by 3 is 4 and 9. Now, looking at my new fraction, is this thing going to be a perfect square? Well, how do we determine if it's a perfect square? With a fraction, it's nice. What we can do is we can look at the numerator and we can look at the denominator. And as long as both are perfect squares, then the whole fraction will be. So 4 is a perfect square, and 9 is a perfect square, so then 4 over 9 is a perfect square. Okay? We can look at 8 over 10, and same thing. So again, we have to reduce it. So 8 and 10 can both be divided by 2, so that's where we need to start, and that's 4 over 5. And then we can look at 4 and 5. So is 4 a perfect square? Yeah, 4 is a perfect square. Is 5 a perfect square? No, it is not. So this thing is not a perfect square. And then finally 1 over 9. Now this one, it can't be reduced. There is no reduction to happen, so right away we just have to ask ourselves, are these numbers both perfect squares? Yes, 1 is a perfect square, and yes, 9 is a perfect square, so that thing is a perfect square. All right, and we can do the same thing for decimals, right? So we can determine if a decimal is going to be a perfect square. But to determine if a decimal will be a perfect square, what I suggest is writing that decimal as a fraction. And then once I have the fraction, I just have to ask myself, are the numerator and denominators perfect squares? Right, so 0.225, how do I write that as a fraction? Well, what we need to first figure out is, well, what is the whole number? Not 0.225, it's 225. Now, 225 has a decimal right after the 5, so how many times did this decimal have to move? It had to move once, twice, 3 times. So what that means, it's going to be over 1, 2, 3, 1,000, right? So moving it once is 10, moving it twice is 100, moving it 3 times puts it over 1,000. Now we need to look at the top and the bottom and ask ourselves, are these perfect squares? 225 is a perfect square, but 1,000 is not, so this one is not a perfect square. And then we can do the same thing for 1.96, right? So 1.96 is 196 over, we're moving it once, twice, so that's 100. 196 is a perfect square, it's 14 times 14, and 100 is a perfect square, it's 10 times 10, so this thing is a perfect square, and I don't know why I put an equal sign there. And finally, 8.1, same idea. We move the decimal place once, so this thing is 81 over 10, and 81 is a perfect square, but 10 is not. And it might be helpful to know which base 10 numbers are perfect squares. So 1 is a perfect square, right? 10 is not. 100 is. 1,000 is not. And so on and so on. So they'll keep alternating. 10,000 would be 100,000. Sorry, 10,000. Yeah, sorry, 10,000 would be 100,000 wouldn't. 1,000,000 would be, right? And they would just keep alternating. Yes, they are. No, they're not. Yes, they are. No, they're not. Right? So then finally, if I actually wanted you to find the square root of a perfect square, so if 16 over 81 is the perfect square, what is the square root of that? Well, again, we just need to look at the top and the bottom. We just need to do each of these square roots separately. What is the square root of 16? What number multiplied by itself gives us 16? Well, that is 4. And what is the square root of 81? What number multiplied by itself gives us 81? That is 9. And this is why it's helpful to have that list of the perfect squares from 1 to 400 memorized, because I can draw on that very, very quickly to get these answers, right? Same thing here. If I wanted to find the square root of 9 over 400, well, what is the square root of 9? It's 3. And what is the square root of 400? It is 20. Okay, and that is it for today's video, and I will see you all in the next one.